Is I've taught you all this kind of a little at a time on bell work and just talking before we actually got here. So today's lesson is about geometric sequences and looking at a pattern and then recognizing, okay, is that a geometric sequence? Is it an arithmetic sequence or neither, right? And then being able to write an equation for those. And that's something that we've been doing quite a bit of. So here's a sequence. What do you think about that one? I heard plus. Arithmetic, right? Okay, we're adding 3 each time. So we have what we call a common difference. Okay? And that common difference is simply positive 3, isn't it? There's another word we use for common difference. What is it? Slope. Slope, right? When we're graphing it, it makes sense to call it the slope. The rate of change. Logan, did you say rate of change? Rate of change, that makes sense when we're talking about actually a real life problem. I mean, that's the rate of change. Common difference makes sense when we're doing this one. So tell me about this next number in the series. 17. And the next one? 20. And the next one? Okay. And so on. And that's great. We need to know that. But we also need to know the zero term. And remember, when you're given a series, that's the first term, the second term, the third term, the fourth term. And what we're saying is, if you think of it this way, when x is, you put a 1 into this equation, you get out a 5. When you put a 2 in, you get an 8. When you put a 3 in, you get an 11. So what happens when we put a 0 in? Yeah. And we need to know that, don't we? We need to know the initial amount, or the zero term, in order to write this equation. And you have to recognize, yeah, that's an arithmetic sequence. It fits this equation, doesn't it? All right, and when we figure it out, we know the common difference is 3, and we know the zero term, or the initial term, is 2, and that will find any term for us. And if we write it as a sub n, this is the way we would write it when we're talking about a sequence. And so if I want a sub 10, can you guys find that? What is it? 32. If I want a sub 100, can you guys find that? 302. So we can find the next term, just add 3. And that's great. But this is something that's important, and that is we can find any term in the series we like. Okay, so that's important. All right, so now let's look at a different type of sequence. I don't want to do that. That's probably enough. What's going on here? We're multiplying by 5, right? So is that a common difference? It's what is it, Cordell? Common what? Common factor. Okay. So we have a common factor. Okay. So this is not an arithmetic sequence, is it? What kind of sequence is it? You with me, Easton? What kind of sequence is it? I only heard half of you. What is it? Geometric sequence. So the common factor is 5. What about the zero term again? We got the first term, second term, third term. What's the zero term? 3/5. Okay. So we know the zero term, or the initial amount. And what's the equation that this one fits? A times b to the x? Okay. All right. So what's A? 3/5. What's B? What? Your common factor. So that's your initial amount. That's your common factor to the x power. Now, I want to write this so that it's a sequence. So I want to write it a sub n equals 3 to the 3/5 times 5 to the what exponent here? N power. Okay. So you'll notice when we put 0 in for n, a sub 0, 5 to the 0, 1 times 3/5, 3/5. We put a 1 in, we find a sub 1, 5 to the first power, it's 5 times 3/5, it's 3. See how it works? Okay, so it's going to give us that sequence, isn't it? Okay. And then recognizing something that is not, didn't I give you this one the other day? Okay, so the Fibonacci sequence. This one, it doesn't have a common difference. We're not adding the same amount each time, are we? We're not. It doesn't have a common factor. We're not multiplying by something each time. What's happening is we're adding the two previous to get the next one. So I could say a sub n, the one I'm looking for, equals the one right before it. You understand? So if I'm looking for the 1, 2, 3, 4, 5, 6, 7th, 8th term, I would take the 7th term and add the one right before that, the 6th term. So I'd add these two together, right? And that would give me the next term. And the problem with this little formula here, it's what we call a recursive formula. We're going to talk more about this later. But a recursive formula, it just finds the next one, which is great. I want the next one. Fine. But what if we want the 20th one? What do we have to know first? The 19th and 18th, right? What if I want to know the 100th term? Right, I got to know 98 and 99. Okay? So recursive is good, and you'll notice up here, I think we figured out a recursive formula when we said, oh, we're timesing by 5 each time. See, because a sub n equals 5 times a sub n minus 1. How do I get the next term? Well, I take the previous one and times by 5. So if I want a term, I just take the previous one and times by 5. So this is what we call a recursive formula. It finds the next one. This one is what we call an explicit formula. It will find any one I want. Okay? Which one's better? The one that makes you so you can find anyone you want. But then let me ask you this. Can you find the explicit formula without really knowing the recursive one first? I mean, the first thing you did was look at this thing and say, how do I get the next one? Times by 5, right? You kind of thought about that first, didn't you? Right here. Was this the one? Yeah. Didn't you think, oh, I'm adding 3 each time? Well, that's kind of the recursive formula. If you want a term, you take the one right before it, and you add 3. This is the recursive formula. This is the explicit formula. So every time you look at a series, you always think about that recursive formula. How do I find the next one? Okay? But then you can take that and make it where we can find any one that we like, as long as it's an arithmetic function or a geometric function. Okay? If it's not one of those two, then you guys are out of luck right now, aren't you? Out o' luck. Okay. So, I don't think we learned anything new today other than explicit and recursive, which isn't on the worksheet or anything. It's just something that we need to talk about in the future, so we'll be doing that. Okay. You want to give one of those to everybody?